online. Like I said, I hold this up and a lot of people recognize the geopump. Had it upside down there. There you go. So that's the geopump. Methods. So what's it used for currently most commonly? And we're just covering the most common methods. There's a lot of different ones. Government, private, and academic acceptance. A lot of consultants use this pump. It is used in a lot of ways for low flow sampling for groundwater, purge and sample methods for groundwater as well. It's also used for surface water sampling applications. The most current one that's really hot is eDNA sampling, and we'll go over that. It's also used a little bit for development of wells. But keep in mind, we've seen customers use this for other applications like injection and a few other purposes as well. So it's a very flexible device. So when we look at the sample methods, you know, there's some methods here we can look at just as examples as well. It's ideal for metals and organics because when you're sampling with a peristaltic pump, the sample only contacts the tubing. And since it only contacts the tubing, there's no metal parts. There's no mechanics getting involved with your sample. That means it's ideal for metals and organics. We're not worried about those coming into the sample. It's great for PFAS compounds because once again, it's only touching the tubing. And as long as the tubing is correct for PFAS sampling, it can be used. If you're using a submersible electric pump for environmental sampling, most commonly they have Teflon parts in them and wear parts. So that could be a concern if you're doing PFAS sampling. Pesticides, once again, you're sampling with just the tubing. Only the tubing is in contact with the water. You have no worries about the pesticides leaching in or chemicals leaching out and contaminate your sample. It is also used for volatile organic compounds, VOC sampling. However, there is some debate out there and some documentation out there where people are worried about the fact since it's a vacuum lift pump, that it might volatilize the sample. So you be careful with which agency you're working with. They may not want the peristaltic pump used for that. However, I can tell you in 20 years in selling and working with these devices and working with our customers, I have not had one come to me and tell me that they had lost a sample. So this is dependent on intended use of data, of course. So keep in mind, you want to make sure that you're in compliance with who you're working with and who you're reporting to. One of the methods I really like to highlight, and this is one that's really been growing, is eDNA sampling. What eDNA sampling is it's used for surface water sampling of rivers and lakes, and it's done to do an aquatic inventory. So basically we're grabbing the water and we're taking it to the lab and we're extracting what's considered like excess DNA that's come off the animals and species in the reservoirs and lakes and rivers. So basically what they're doing is they're running a DNA profile. They can see if there's a trout in there, if there's another type of species in there that they don't want. So a good example, it's great for detection of small and rare species that are hard to find. You can spend weeks and months sampling and monitoring a reservoir and not see this species, but you can detect its DNA in the water. It's also great for early detection of invasive species. So if we're out there and we're trying to sample water and we try to find invasive species, one of the most recent concerns we've had here out in the West in the Rocky Mountain region is zebra and quagga mussels. So when we look at that, we can actually use this device to sample the surface water and to see and run the DNA profile and see if those are actually in the reservoir, right? And this is a big concern for water supply as well as recreation. We're going to go over a little bit on the Geotech technology here. It's a suction lift pump. Once again, that means it is pulling the sample, it's pulling a vacuum on the tube to pull the water through. And we're also going to go over some system configurations. The Geopump technology is, once again, a suction lift pump. And I'm just going to kind of hold this up to the camera. And so for the rest of the crowd here. When we open this up, we can see there's rollers. It uses a flexible tubing of a particular size, depending on what you're dealing with. And these rollers will squeeze the tubing and roll it forward. That pushes an air pocket forward, which creates a negative pressure behind the roller. That negative pressure, i.e. vacuum, is what's pulling the sample up the tube. Keep in mind, since we're doing vacuum lift, we're going to have a limitation on how far we can pump. What is our max depth? So when we look at what the geopump can lift at sea level, it can lift up from 29 feet. So that means from static water level. Water enters the intake tube and can actually fill up to hydrostatic pressure. So in other words, we're not going to be lifting from the intake of the tube. We're only lifting from where the water level is. All right. So that means it can be very efficient depending on where our water level is. I can actually, we show 70 on this unit, we're showing like 70 feet down, but we're only having to calculate our lift from where static water level is. That's regardless if we're off the side of a boat or we're dealing with a well. All right. So that's our main concern. And it makes it great because we can sample really deep with a very simple device, but with the one criteria being that we have that water level within range for us. All right. I'm actually going to go back to this a bit too. So going back to groundwater sampling, you can see on the left, that's our well. On the right side is the boat profile. And one of the other things I've been working with our clients on is I do a lot of work with surface water, is a lot of people are out there on reservoirs doing what's called a profile. They're lowering an instrument all the way through the reservoir and taking readings at different intervals. If they see some readings like some chlorophyll or some blue-green algae that is something that they really want to get a sample of, maybe it's a toxic algae, they want to sample that. What's really convenient is just go ahead and attach a tube to the cable for the monitoring device and lower it down. If you see something that you need to get a sample of, just turn on your peristaltic pump and sample from that exact point. So instead of using a Kemmerer sampler or a bomb sampler, you can actually pull a direct sample from that interval and keep that tubing attached. And as you lower down, each time you find something new, you can purge your line and take a sample from that interval again and keep lowering. Yes, Jim?
Do you have some sort of a weight that you can put on the end of the tubing?
Yes, we do.
To make sure that it's vertical?
Yes, absolutely. But in this application where you're just clipping it to your monitoring device, your sonde, as it were, that's your weight right there. So it's going to pull it right down, and you can have your intake right by where your sensors are. So you know, like if you cross a thermocline, you can actually just sample right beyond that thermocline. You can be very precise that way. Whereas with a bomb sampler, you're having to kind of figure out your depth based off marks on a cable. So it makes it a lot more accurate. And a lot of those profiling devices now have depth sensors. So you know exactly what depth you're taking the readings at and your sample. So suction lift, there's a little bit to learn on this. So, okay, on this example, can a geopump peristaltic pump be used for low flow sampling in this scenario? So when we look at this, we want to sample from 73 feet from top of casing, but our water level is 19.7 feet from top of casing. Can we use it? Anyone?
Depends on what elevation you're at.
There you go. We'll go over that in a second. Definitely. Yeah. So someone said, depends on what elevation you're at. So yes, does depend on what elevation you're at. I'm going to say yes right now, based off sea level. All right. So yeah, absolutely. We can do this at sea level. That's correct. We can use this for low flow sampling at that depth. And keep in mind, stay for the next presentation. We will be covering low flow sampling right after this one. Geopump technology. So yeah, suction lift based on elevation. So great point out right there. That was actually in the next slide. So we're going to look at elevation loss on vacuum lift pumps. All right. We're here in Colorado. We're at 5280. So we're going to use that as an example. We're 1 mile high. But we have customers that will take these up even beyond an altitude into the mountains. And so that's sometimes when they're using this equipment, we would need to sit down with them and say, hey, we need to help you calculate how deep you can actually lift from. So right here, we have a calculation. It's elevation times 0.0115 equals our loss in elevation, or our lift. So max suction lift at sea level minus the X equals now our actual lift. How does that equation really look? And I'm sorry, I'm hitting you guys with equations first thing in the morning. I hope you had coffee, because I know equations can be a little boring, but this one's great because it's really needed. So elevation, 5280, that's Denver, Mile High City, right? We do times 0.0115, we get a loss of 6.072 feet. So we take our max suction, subtract that 6 feet. That means at our altitude, a max lift of 22.9 feet is available to us. All right, so we lose that lift on altitude. You can build a geopump however you want. It's a very configurable product. What we show here is different power configurations. You can get them DC only, hardwired, so you're just running off a 12-volt battery. It makes it very portable. We also have an AC-DC with an interchangeable DC power cord. Highly recommend if you're going to go DC only going that direction anyways, because you can just field replace the cables as needed, right? So if you shut a cable on a tailgate or a car door, accidentally cut it, things happen in the field. You can actually just get a DC power cord right away and replace it on your own. We also have the AC-DC models with AC cord or AC-DC with AC and DC cords. That hands down is our most popular configuration, because sometimes when you're done sampling out in the field, you get back, maybe you couldn't filter in the field, you can refilter your samples back when you get to the office or to the lab. So you can actually put it back on the lab bench and use wall power. So you have options. Pumping stations, there's the Series 1 and Series 2. Series 1 has just one pump to 350 RPM. The Series 2 has two pumping stations. There are 300 RPM and 600 RPM, but please note you can only use one pumping station at a time. You can't use both pumping stations at the same time, all right? You can get them with a field case or no field case with foam, and you can also get them with a modular battery and charger. That will get you a couple hours out in the field right there. And pump heads, you can go ahead and buy without a pump head if you're just replacing a unit and you still have a good pump head, or you have a pump head that will match the unit and you want to use it. Or we have standard pump heads, easy load pump heads, and easy load 2 pump heads. The third option, easy load 2, is what we rent and sell most commonly to our customers because it is the most flexible one. It has 3 different tubing sizes that you can use with it: size 15, 24, and 36. That means I can use a 1/4 inch suction line, a 3/8 suction line, and a 1/2 inch suction line with that pump. So in summary, and I moved pretty quick through this, I had 20 minutes to go through it, but you know, I'm 5 minutes early. But so in summary, this pump has been used since 1978. It is the workhorse for the industry, really. A lot of sites do qualify to be within that 29-foot range in sea level. We see it used in a lot of different applications, like I said, surface water, groundwater, laboratory analysis. We have a whole bunch of other stuff that, you know, purposes for it. We see people using it to inject dye and tracer for dye and tracer studies. There's a lot of different uses because you can actually calculate with this pump your flow rates by just using a beaker, and you can vary the speed. There's a lot of different applications for it. It's probably one of the most flexible products out in the environmental market today. Has a wide range of sampling methods and applications, like I just discussed, and multiple system configurations. Even if you buy it one way, you can always have it rebuilt and sent back a different way. We can always upgrade these units. So there's a lot of flexibility in those. Any questions on this? Yes, Jim?
You talked about the 300 and 600 RPM
Yeah.
capability. What's the pumping rate for those units?
Okay, that would be dependent on the tubing size. Once again, if I'm using a size 15.
So say you use a 1/2 inch tubing size, which would be the biggest size.
Yeah.
What would be the pumping rate?
I don't know that calculation on top of my head, but if we do have a tubing calculator, so you can go online, and we have a link where you can look at our tubing sizes, and it'll give you a kind of a flow rate per RPM, and you can use that to calculate what your max flow rate would be.
So are you talking 5 gallons per minute or 15 gallons?
So
No.
I can address that.
Yeah.
So the size 15 silicone tubing is 1.67 mils per revolution. So if you pick up a pump that does 350 RPM, so 350 by 1.67.
Okay,
And then the 600 RPM, you may get approximately a liter of size 2.
okay, that's what I thought.
Yeah.
Okay,
And I think you can almost get a gallon per minute with a size 36.
Yeah, but yeah, you can't get up to like 5 or 15 gallons per
yeah,
minute,
I
something
thought
like
it was
that.
my flow.
Yeah, yeah, it's definitely a lower flow rate. It's not going to replace the flow rate of a submersible electric pump. So, any other questions? Any applications that anyone's using these for right now that you'd like to share? All right.
Something else to add, I guess, on the suction lift, the specifications, if you go with a larger size tubing, so size 15 is a small performance size tubing, which has a max lift area of 29 feet. But the size 36, for example, has a max lift at sea level of 26 feet. So reviewing the spec sheet and kind of understanding your site characteristics, well, wherever you're sampling from, to make sure that you're able to lift with the appropriate tubing and elevation.
No. Any other questions? We have about 10 minutes till our next presentation. So like I said, I went pretty quick through that and I apologize. But it's a pretty simple pump to go through.
I'm gonna try to get the owl working.
Yeah.
Do you think you can run over on the low flow?
Yeah, I can run it.
Let's see here, let's change the device settings. Let the echo.
We're trying to activate the 3-dimensional camera right now so people can see the room. And if there's any questions, people can actually see who's asking the question.
Do you have any questions? No. All right. There you go. So now you have the owl.
All right, cool. We're going to check the chat real quick, see if there's any questions on chat. Any questions from anyone online right now? All right. So what we're going to do is wait a few minutes and before we start the low flow, because I wanted to see if there's people coming in late for that. While we're doing that, let's kind of do a check-in with everybody and see where everybody's from and also where everybody's logging in from. I would love to hear where people are logging in from, but who is here from in Colorado? All right, who traveled out of state? Okay, let's play the game. Who traveled the farthest? Okay, who thinks they traveled the farthest?
Virginia Beach.
Virginia Beach, that's pretty good.
Texas.
Texas, oh, you guys are pretty close. Yeah, we could throw a stone and hit you. All right. Nevada, great, great. You came up here for the air-conditioned weather, right? Now we're at 95 degrees. Maybe it might be 5-10 degrees different. That's about it. But it's a difference, right? There you go. There you go. For those who are logging in online, where are you from? If you guys don't mind typing in the chat, let's see who's logging in from where. I see a David Kraft, a Melody, Kiana, Matthew, Nick, Michael. Who's logging in from where? All right, not seeing anything pop up on the chat. You can, let's see here. Yep. All right. Well, we're going to give it a pause and give it a break. If anyone wants to get an extra coffee or water, hit the bathroom. We'll be starting here in about 5-10 minutes.
Yeah, I just opened up the chat for those.
I just opened up the chat so people can unmute themselves.
Okay, you guys are unmuted, so if you want to, you can even ask questions now. So I'm going to stay on right here, see if you guys have any questions that come up.
Thanks, Jason.
Yeah.
Jason, I have a question.
Yeah.
This is going back a number of years, and but several years ago, I had pushback on VOC sampling off of a peristaltic.
Yeah.
And was told by a regulatory agency to pull out the tube and sample from the bottom to reduce volatilization, which seemed really silly to me.
Yeah.
Can you address that? Have you dealt with that in the past?
I haven't heard about like sampling from necessarily the bottom, right, to prevent volatilization. The main concern comes when you really start hitting the max lift for the pump, and you're really at that where you can actually sometimes see bubbles forming in the line because you are pulling such a vacuum on it. If you're doing that and you see those bubbles, that's a clear indication that the gases are expanding inside the water and inside your sample, and you're definitely getting that volatilization at that point. And I believe that's where that concern comes from, because VOCs love to come off a lot faster than even oxygen does from water. So that's one thing to be concerned about, right? Another thing is like when you're filling a BOA, like a 40 ml BOA, you want to make sure you're pumping at a nice consistent rate, not too slow. Because once again, if you're pumping too slow, you want to fill that BOA consistently, get that meniscus on it, cap it, no air bubble. It's actually a great device for that, because you can slow it down just enough to do that, fill it up, get that meniscus, cap it, and be done, right? So the variable speed on that really does help out with that. And the other way it helps out is with field filtration. A lot of people get big grab samples and they're field filtering their samples. It's really easy to hook up a filter to it and do your field filtration with this as well. So we sell filters, a ton of filters, because of that purpose, from flat stock filters to capsule filters and stuff like that, because there's a lot of different types of filtering out in the field. Some people need that sample to be collected right off the membrane. They're going to scrape that sample, right? Others just need to filter something out, for example. And so once again, that field filtration and that portability, it makes it like your mobile lab unit, right? So that's, once again, I think why it's so widely accepted is. And for VOCs, once again, we just, the agency told you what you had to do, follow those criteria if you're going to use the pump, or use a different sampling device.
Sure.
Thank you. Yeah. Thanks for coming. I was just thanking everybody for coming in. We have, we're just excited this year that we can do this online and in person. It does really expand the reach on it, being able to reach out to people on field days and talk about equipment, and have our vendors be able to present and show off what's new with them, and do some training and support too with our customers, and just really be a better resource for everybody. So we're just excited about the duality of this year, because it used to be only in person for Geotech. And that's where we're at. So I don't know who spoke, but thank you for reminding me to turn the mic back on. I appreciate that.
Not a problem.
Is that you, Frank?
Yeah, from Oak Environmental.
Oh, nice. Good to hear from you, Frank. How you been doing?
Pretty good. Yourself?
Good. There we are. So we were actually asking earlier who traveled furthest or logged in the furthest. You're coming in from Canada, so that's great. That's great to hear from you, and we'll talk to you and put a face to the name. You and I have talked for years, so that's amazing.
Good to see you.
Anyone from out on this web presentation that's out of the country? So I think, Frank, you win the award. Farthest distance means also you cross the border. So there you go. So that's what's great about doing it this way this year. So awesome. So we got about 3 minutes before we start the presentation on low flow sampling tech and method guidance. So about 3 more minutes to grab a coffee, hit the restroom, grab some water. Just there you have it. Any other questions from our web guests? I notice we've grown online here.
It was a couple months ago, so.
Good to see you, Kathleen.
How's it going?
How's 2.0 doing?
Doing well, man. Doing well. I'm excited to see what you guys have going on for this stuff.
Yeah, we're excited to be doing it like in person and online this year. So this is fun.
How is in person?
Good to see you.
Yeah, you too. How's the in person going? Is there a lot of attendees in person there?
Yeah, actually, I think we're gonna have quite a bit. Yeah, Andrew's waving his arms in the background there, like he's on a roller coaster, which is exciting. Even out here in Denver, like Elitch Garden's open, right? We can go ride roller coasters again. So.
Exactly. Awesome.
Stuff.
Well, I'll mute now. So I just want to say hi.
All right, we're at 9:30, so we're going to start getting on here with low flow sampling and pump tech. So let me make sure. Can everyone see the share screen that says low flow sampling, pump tech, and method guidance? Anyway, if you can't see it online, you're unmuted. You can actually chime in real quick and say, I can't see it. We're good? Okay. All right, so we're going to get moving on here. So next presentation here, we're going over low flow sampling, pump tech, and method guidance. We're going to be focusing on one pump technology though first, okay? So we can't cover all the different sampling pump technologies in this time frame, so we're going to be focusing on one pump technology, but understand there's other pump technology that cover that, and I'll briefly cover those as well. As we just discussed with the GeoPump peristaltic pump, that can be used for low flow sampling as long as we're within the vacuum lift range and it's accepted by the regulatory agency we're working with for what we're sampling for. All right, so for some reason that didn't move forward. Let's get back to that screen real quick. Let's see. Maybe now it'll work. Okay, so overview, we're going to go over the low flow sampling method. We're going to cover what EPA's guidance on that method is. Researched that again just recently, and there's some new additions to it. So it's one of those things that's evolving, and it's something that, you know, it's worth checking in on a regular basis, because as things evolve in our sampling industry and we add new things that we're sampling for, like PFAS and PFOAs, that changes a little bit what we can and can't use in our guidance. Considerations in low flow sampling methods, and common equipment and supplies. And then at the end, we're going to have some time for questions. All right. And this is one of the presentations I get the most questions on, because I think there's some mysticism around low flow sampling, and we're here to help eliminate that. Okay. And cut through that. So first of all, why do we sample groundwater? Why are we doing this? What's the job that we're doing here? Groundwater is essential to the economic viability. It's our livability, our drinking water supplies, and it comes out to ecological sustainability for our environment. So that's why we're out there sampling, is we're trying to figure out what's happening with our groundwater. Organizations including USGS, state geological surveys, and environmental consultants regularly monitor groundwater for natural and also introduced contaminants. So we're out there collecting background data, also looking for contaminants, or both at the same time. Because groundwater travels, contamination can have widespread implications. Let's face it, pollution doesn't know what a boundary line is, right? It's going to go where it's going to go. If organizations are found to be responsible for groundwater contamination, then they're going to have to be accountable for the remediation of that, right? So that's the other thing, is we're out there doing investigative work. To understand the low flow sampling method, it in many ways replaced the purge and sample method. So the traditional purge and sample method, which is purging 3 volumes of well casing before we take a sample, the purpose was to get the formation water. because we don't want the well water. The wells can get intrusion, they can get contamination, they can get stagnant, they can get stale. If we're not getting good flow through that well casing, we're not getting the true formation. So what low flow and purge and sample do is we're trying to get the formation of water. We want the water outside the well. Purging 3 volumes, of course, we're going to get that, but we're doing a lot of flushing. We're doing a lot of disturbance to the well. Low flow intends to create less disturbance and create more sample integrity, while also reducing purge water volumes. So the objective is to place the pump directly in the screen and sample the aquifer to get formation water. That's true of both purge and sample, right? So purge 3 volumes or low flow, we're doing that. It requires the pump to be dialed down to a very low but consistent flow rates. Now that is key. So we want to be able to control our flow rates accurately if we're going to do low flow sampling. So that's going to be a key factor in doing the sampling method. It requires the flow rate of the pump to be matched to the recharge rate of the well. So not only do we have to be very matched, we also got to be monitoring the recharge rate of the well for the formation water, which is, again, what we want to sample. We want that formation water. Now, people online are not going to be able to see this, but if you can see the diagram and you see the sampling pump, what we're trying to do under low flow, instead of getting all those gray arrows, which is purge and sample, and purging all that through this casing, we're trying to create that flow rate right there at the pump and pull the water straight in from there. All right. It's a low stress method that leads improved sample accuracy in a couple different ways. Number one, we're not stressing the well. We're not creating a lot of disturbance, a lot of sediment kick up. We're not doing a lot of disturbance to that well, right? The other thing is if we have different teams going out and sampling the same wells all the time, but it's different teams, and we're following the low flow guidance, those teams are going to have repeatability because they're following the same procedure. They're creating the same scenario every time they go out there, regardless of who's operating the equipment. So that increases your reliability. Low flow samples do not work in very low yield wells though. Keep in mind, we have to have a consistent flow rate and we can't overdraw down the well. If you have a very low yield well and you just dry out the well, that does not meet low flow. You just purged it. That's more of a purge and sample method. So keep in mind, it may not work for those types of wells. It can take more time to purge and sample on this method, especially in low yield wells. Once again, if we're having to really sample slowly into a low yield well, that might take longer than a purge and sample method. So just be aware of that. But in a lot of cases, it can be quicker. Multiple pump technologies can actually be used in low flow sampling. So we are flexible. Today we're going to discuss the bladder pump, which is being very, used more and more and more, and has more applications every day for it. But low flow is ideal, and bladder pumps just get together with low flow really well. And I have a couple examples of a couple bladder pumps here. This is a PVC bladder pump. You actually can, in some ways, I don't know if it's showing up online, you can actually see the bladder on the inside that actually gets squeezed for the sample water, and this is the outer casing. And this is a stainless steel design, same idea. It's just designed for greater depths and survivability. And this is a portable pump, so this one's actually designed to be used in portable applications. So we have some considerations in low flow and things we got to understand about our site before we can operate. We do have to verify the recharge rate of the well and verify pumping rate will not exceed it. So this means we actually have to monitor while we're pumping and be very observant of what's going on with our water level. Ways to monitor this include water level meters, just using a water level meter to keep detecting our water level and making sure we're there. You can also use pressure transducers that actually have, connection to a computer so you can watch on your screen and watch the water level on your computer. Or we have water level meters that we manufacture here that will actually connect to the control device. And if you exceed a certain depth, it'll actually turn off the controller. So it's actually working like a third hand for you out in the field, where it's just going to control that and optimize that for you. So it automates the sampling process a little bit for you. You need to verify the depth to pump. Is it in the screened area? Now keep in mind, a lot of times we run into situations where you got to go really deep. But if water level's at a point where we can have a bladder pump, we can actually do something called a drop tube assembly, which actually connects to the bottom of the pump, lowers a weighted intake, and then we can sample from really deep. But the criteria being the pump is still submersed. So I could sample from 1,000 feet if my water level is at 200 feet. My pump's operating from 200, we're using hydrostatic pressure to fill that pump. So we're actually still getting that water from down at 1,000 feet. So drop tubes can be used. Yes,
Pump
Richard?
has to be submerged.
Pump does have to be submerged. We can't vacuum with that, right? So it still has to be submerged. So that is one criteria, all right? Good question. Site conditions such as power and drive sources need to be considered. What are we gonna use out in the field to operate the equipment? And then what pump is desired for use? Once again, we have bladder pumps, submersible electric pumps, and peristaltic pumps that can be used in this application. And some people might be amazed, maybe they've thought, and this is some of the mysticism, some people come to us saying, I need a low flow sample, so I have to have a bladder pump. No, you don't have to have a bladder pump. You have to have a pump that you can actually control the speed on, so you can optimize your flow rate. And that's what's crucial. Now, you may need a bladder pump depending on what you're sampling for, and that's something we needed. So let's go over what you need in the field. What's your kit out in the field? Well, you need a variable pump and controller. You need a water level meter in an Interface Pro, possibly if you're going out there and detecting product levels as well. A power source, if a generator is to be used 30 feet away is what EPA guidance says. So you need to keep that 30 feet away from where you're sampling and filling your samples. That's the minimum. Field parameter monitoring instrument with a flow through cell. This is from the EPA as well. And if you haven't worked with haven't seen a flow through cell before, basically what we're doing is we're putting our sensors in a sealed environment and we're pumping through, displacing the air volume and pumping and discharging out the top of that cell. What that does is it creates a zero headspace environment and it allows you to monitor for what we need to do next, and a crucial part of low flow sampling, which is monitor for stabilization. EPA does not want this done in a bucket. It needs to be done in a flow cell, okay? And there's also certain criteria too. Your flow cell cannot be heated up or frozen, right? That changes the sample. Extreme heat and sunlight can actually volatilize your sample even with the flow cell. So there's also, you need to be as close to the well as possible. And if it's a hot sunny day, like from Arizona over here or here in Denver, they also recommend shading your sample flow cell, shading your sample tubing. But that same is true during the winter when we're in a freezing environment, right? We can't have our samples starting to freeze up on us and get too cold. That changes things as well. And it could also make it very hard for us to know when we've actually stabilized if temperature is changing on us, because temperature is one of our stabilization criteria. So other equipment. Rate, you're going to log what you're sampling for. You need your sample bottles, decontamination supplies, and possibly a PID or FID. If you're sampling for VOCs, you may be opening up the well and screening the well to see what your VOC off-gassing is from that well, right? And also, like we just covered, equipment to keep tubing from heating up or freezing, as again, heat and sunlight can cause volatilization. And we don't want to lose that for sampling for VOCs. One thing I don't have on here that's also great to have is a Y valve, because you never want to sample post flow cell. Flow cells are commonly plastic and metal with O-rings and nooks and crannies that are hard to decontaminate. So you don't want to use your sample or get your sample post flow cell. So having a T valve or a Y valve pre-flow cell that you can get your sample from is really key, actually. So keep in mind that that's another addition you'd probably want. So using a bladder pump for low flow, we have our considerations. We're going to, this example, we're going to focus on using bladder pumps. Although portable pumps are allowed, dedicated systems are preferred by the EPA to reduce particle entrainment. So what is it? What's a dedicated system versus a portable system? So a portable system is intended to be moved from well to well to well, and you decontaminate from well to well to well. Well, when we go through the EPA guidance, one of the things they want to do is make sure you lower the pump as slow as possible into the well so you don't disturb it. If your pump is already dedicated to that well, which means it's already installed and it has a well cap that you can hook up to and sample from, you're not having to worry about that introduction of the pump to the well. It's already there, right? Also, they like it because there's risks in the decontamination process that you didn't do it right. All right, so if you don't decontaminate your portable equipment correctly, and that also requires more field blanks, more lab analysis, you get the idea. It becomes more complex. So dedicated systems aren't actually preferred by the EPA for low flow sampling. Your bladder pump should be sufficient to provide a full 40 mil squeeze. It's not mandatory, but considered best practice. So that means when the bladder pump squeezes, ideally you want no less than 40 mils per squeeze if you're filling a 40 mil VOA for VOCs. So that's really more about the VOC sampling, because if you're doing multiple squeezes into a VOA, while you're waiting for the next squeeze, we're losing VOCs. So we want one squeeze, fill the VOA, cap it, be done, right? So that's considered best practice. Now, they do actually, for VOC sampling in the EPA guidance, talk about using PTFE, i.e. Teflon, or PTF line tubing for VOC and SVOC, pesticides, PCBs, and organics. So you reduce the leaching or possible absorbance of those contaminants into your sample tube. So they do prefer that, but not if you're sampling for PFAS and PFOS. All right, so there's, it depends on what you're sampling, right? So keep that in mind, that there could be a difference depending on what you're sampling for. So that's their general guidance for VOCs, and all those other contaminants, it reverses when we go to PFAS and PFOS. Procedure, we're going to go out there. We're going to remove our well cap. If we're going to screen it with a PID RFID to measure the rim of the well, if applicable, like we said before, if that's a VOC site and we're concerned about off-gassing, that's always great to have out there and understand what our off-gassing is. Measure your water level before installing pump. This is crucial. We want to know our water level before we start anything, right? It's the first thing we do when we get out there. I always joke with people in our industry, the water level meter is like a hammer to a carpenter. You use it daily, use it every time, right? You lower the pump cable tubing slowly to minimize disturbance. Once again, this is in the portable application. We want to go really slowly. We're not going to send it, we're not going to just javelin that pump down the well. We're not going to do that, right? We want to make sure that we lower it nice and slowly and make sure we're not disturbing and stirring up a lot of debris. Tubing above the well should be at a minimum to reduce heating and cooling. We just covered that a little bit on the flow cell, right? We don't want to have just say it's a 20-foot well and we have 100 feet of tubing and we just don't want to cut the tubing. Well, then you have 80 feet of tubing on the surface coiled up. Your sample's going to heat up. It's going to cool down depending on the environment. You could volatilize your sample. It's just not best practice. So best practice is get close to the well as possible. And we know that's not always doable depending on certain sites, right? Maybe clearance around the well makes it difficult, but do what you can. Measure water level again. We just introduced something to the well. That's going to raise water level. We want to make sure that water level comes back down to normal again before we start monitoring, because we don't want to take that water level, and it's going to naturally come down anyways because it's going to reach equilibrium. But if we consider that part of our initial water level, and we're going to actually see that as drawdown. We don't want to mistake that for drawdown. All right. So we're going to measure water level again before starting a pump, or use a pressure transducer to track the drawdowns. Again, that's also acceptable. Procedure continued. From the startup until samples are collected, purged water should be collected in a graduated bucket to determine total water purged. Right. We want to understand how much we're purging. Yes. Oh. Okay, I got 2 minutes, I guess, so I got to move along. So we're going to slowly increase our pumping rate or adjust the bladder pump cycles as needed to increase the pumping rate while monitoring the water level. So we're going to keep monitoring that. We're going to make sure that we're not overdrawing down. We're going to try to match previous pumping rates if done previously at the same well. This is where it comes back to repeatability. If we've had a crew out there before and we've achieved a good low flow sampling event, we should know already generally what the pumping rate should be. It might change due to seasonality, right? Groundwater tables do fluctuate, but once again, we want to try to match that. We adjust the pump until there's little or no water level drawdown, and typically drawdown ideally should not exceed 0.3 feet. But if it does exceed it, we want to make sure we reach stabilization. So even if we come a half a foot down, but we finally achieve stabilization, we're good. They're just saying generally best practice 0.3 feet. And we continue purging. When we monitor, record the rate every 5 minutes and record any adjustments. During purging, we're going to monitor for field parameters for stability at 5-minute intervals. And the pump's flow rate should overturn the flow cell at least once between those 5-minute measurements. So that's ideal, but consider some flow cells are bigger than others. So keep that in mind. If you're dealing with a site with a really low flow rate, you're going to want possibly a smaller flow cell to turn over. All right. Some people get some really big instruments out there with huge flow cells, and that might be not achievable. Note during the early phase of the purging, the emphasis is not minimizing and stabilizing. As it says, during the early phase is minimizing and stabilizing. So not got on my slide that on there somehow. But we want to minimize the stress of the well. We want to make sure that we're reducing that as much as possible. All measurements excluding turbidity must be done in a flow cell. All right, so you can do turbidity in a vial method. It's a little bit more complex because you're having to stop and do a vial, but some instruments do have turbidity built into them. That's actually a stabilization parameter that we're going to look for. And samples should be collected after stabilizing. That's what we're looking for. When our parameters have stabilized, temperature, conductivity, pH, all those have stabilized, we know we're getting the formation water now. We're not getting just the well column water, right? We want the formation water. All right, so I think I danced through that 2-minute warning pretty quick, just went over it by a minute. So low flow sampling reduces purge water collected. This is key. A lot of us have to, if it's contaminated groundwater, we have to dispose of that water. And where can we dispose of that? We have to dispose of that at a treatment facility. That costs money. So that's another great thing to consider with low flow sampling is your disposal. How much water are you going to collect compared to the purge and sample method, right? So that's a savings right there. Bladder pumps are ideal tool for low flow sampling, along with variable speed pumps, submersible electric pumps like a Geosub 2 or something like that can definitely be used. Portable systems are allowed, but dedicated systems are preferred. They increase reliability, they increase decrease risk for cross-contamination between wells. So dedicated systems are definitely preferred. And you'll find that they add reliability and they also reduce time and money, because if you're just walking up to the well and starting up and sampling versus having a decon, reset up everything, do all that, there's a lot of time savings there too. So that's it right now for that. Any questions? And our MS Teams logged in people here, any questions from you as well? Mics are unlocked, so you guys can unmute yourself and ask any questions you would like. I have a question in the back.
I know you said that low flow works best at flow rates that are greater than 50 mils per minute.
Yeah.
We have, especially in Denver with like small tight formation.
Yeah.
You don't get that without decreasing the water level.
Yeah.
So that creates problems for temperatures.
Yep.
Freezing conditions and that 40 mil OF thing.
Yeah.
What are your recommendations?
At that point, you have to get, it's going to be a purge and sample method. Really, you're going to be purging the well and sampling. So, and that's going to take a lot longer because with that low yield well, you're going to purge it, let water come back in, purge it, let it come back in. We've had clients that have had wells that take days to do that. Right. You could possibly use a no purge, but keep in mind, no purge sampling methods require that, that you have good flow through the screen. So it'll be representative of the formation water. So you could possibly use those, but you got to be assured that that's what you're going to get. All right. Yes.
That, the 50 milliliters per minute
Yeah.
number, is that written somewhere in EPA method or guidance?
Yes, it is actually. So, but here's the thing. Once again, that's best practice. They're saying this is best practice. Ideally, site conditions are conditions. Every site is different. We have to adapt and overcome, of course. But that's their guidance. That's what they prefer. And like just pointed out here in Colorado, we're going to have in our territory some wells that have extremely high yield. If I'm sampling near the Platte River and it's sand and gravel, man, I'm going to get water pretty quick. Achieving that is going to be easy. I get near the hogback where we have clay and bentonite formations that are really tight. It may be more difficult to achieve that.
Your question came in, can low flow sampling be used for metals analysis, VOCs, and PFAS sampling?
So the question came in online, can low flow be used for metals, VOCs, and PFAS? Yes, it can be used for all three. Once again, we're trying to get the formation water, so it's not, sample specific on what the contaminant or the background is. You can use it just for getting background formation water data. You can use it for trace metals. You can use it for VOCs. In fact, it's great for VOCs because we're pumping very slow. We're not really flushing the VOCs and stuff like that in the well and disturbing things that way. Especially if we have a product layer, right? If we're purging and sampling and we have a product layer in that well too, and we're purging that and we're stirring that up in the well, we're going to wash that product past the screen and everything. It's going to complicate things. If we can actually, skim off a little bit of that product, get a pump down past that, and then purge through that way, we're going to be a lot more accurate on what's going on below that contamination layer.
Another question, water pump systems being used in brackish or saltwater environments, especially where saltwater treatment.
Yes, they can be used in brackish and saltwater environments, but be mindful if you're dedicating the pump or what pump materials you're using in brackish and saltwater. You may want to go, for example, I handed around the PVC pump. I would rather use a plastic pump than a stainless steel pump in those environments because of the mismatch between stainless steel sometimes and saltwater and brackish water. So you just got to look at your pump materials. No. Yes.
What tubing do you like for PFAS?
So for PFAS, they're recommending HDPE tubing. All right, so that's a formulation that you have to look for. There's LDPE, HDPE, and then of course we have our Teflon at PTFE tubing and PTFE line tubing. But those, again, the PTFE tubings are not what we want for PFAS sampling. And that was like I said, I went through the EPA document just recently, and that was in there, right? And we've all been hit with PFAS as a new contaminant of emerging contaminant of concern in the last 5 years. So for the EPA to already jump in and say, hey, we want you to use this tubing, but not for this, means they're really that's pretty timely, right? So they're keeping it up. So it's always worth looking up the document and just reading through it and understanding it fully. Yeah.
Yeah, so on that same note about the and well as or just
I would just settle with HDPE at that point. Yeah, honestly, there's no need to keep swapping tubing and redisturbing the well and stuff like that. You'll be safe with that. They're just saying the best practice pesticides would be the tubing, but if you're out there and you're concerned about those and PFAS, let's just go with the HDPE tubing.
Hey, Jason.
Nick.
What would be an example where you would use the Teflon lined tubing as opposed to the tubing that's just composed of Teflon itself?
Excuse me? That broke up.
What would be an example where you would use the Teflon lined tubing as opposed to just the Teflon tubing itself? Are there?
Yeah, you can use the Teflon lined tubing. And basically what we're doing at that point is we're using a low density polyethylene tubing that has like a Teflon lining blown through it. And your sample water is only touching the Teflon lined tubing. And one of the advantages too of that tubing is it's less expensive than just straight Teflon tubing, because there's a lot less Teflon involved at that.
Got it, thank
Good
you.
question, Nick. Thank you. And thank you for logging in today too.
We were gonna camp there, but there's nothing until October.
How's everybody doing? Who here purges and samples? Yeah, it's a lot of fun, right? So today we're just going to go over a couple of particular pumps. And if you have experience with it, I want to try to make this a little bit interactive to some degree. I'll probably cover some things you already know, but the goal here is to try to come up with something that you may not have heard before or something that will help you out in the long term, okay? Today we're going to cover the SS Geosub and the Grundfos Ready Flow 2. These pumps are designed specifically for purging and sampling, and that's a tall order because I think a lot of people want to do a little bit more with these pumps. These pumps will deliver a continuous flow during sampling. So if you're doing well stabilization, you can manage the flow rate with a controller to go from a high purge rate down to a low sample rate. Okay. Both pumps require routine maintenance. This is something that over several years I've found that if you don't have the parts with you in the field, you're not going to find them at Home Depot or Ace Hardware. And if you think they're expensive on the front end, air freight to wherever your site is in a lost day is a little bit more money. Pumping sandy and gritty water will accelerate wear and tear. These pumps are designed for pumping good developed wells, clean groundwater for purging and sampling purposes. I can't emphasize that enough because it's a real critical part to the longevity of these pumps. Decon is a mandatory process. I always advise people, make sure you know your pump. Carrying spare parts to succeed. If you take care of your pump, it's going to take care of you. There are parts in these pumps that are designed to wear. They're soft parts like Teflon bushings, Teflon wear plates, O-rings, things of that nature that with use will fail at some point. And it's usually when the regulator's on site and it's Friday afternoon and you got to rush off to get samples to the lab and it's the last well. If you've ever had that experience, I have. It's a lot of pressure. Lost time in the field is a mojo killer. So if for some reason something simple could solve a problem and you don't have it, all the momentum that you may have going into a project can be lost. Air freight costs to field sites can be a time waster. Spare parts are easy to carry and there are only a few. So we'll go over some of these items as well. Both pumps will require a power supply. Whether dedicated or portable, a generator or wall power is necessary to run the pumps. The Geosub can run all day on a small 1,000 watt toaster oven sized generator. That's kind of how I reference it, because if I've gotten a call over the years about what size generator should I use to run my pump, the Ready Flow 2 always requires a much larger generator, usually in the 3,000 watt plus range. You can use a 2,000 watt if the motor lead is shorter in length, usually less than 200 feet or less. And the reason for that is there's resistance in the wiring that beyond 200 feet, a 2,000 watt generator, you're going to get varied results. With the SS Geosub, you're taking that incoming power from a generator and that controller is converting it to a DC current to operate the motor. It's very energy efficient. The Ready Flow 2, the reason it requires such a large generator is it's taken single phase power and it's converting it to 3-phase power. In the United States, we don't deal with 3-phase power very often. 3-phase power is very efficient. And when Grundfos designed the Ready Flow 2, the best way they could get the pumping depth and the pumping flow rates was to miniaturize a 0.5 horsepower motor. And in order to get the motor lead diameter of such a size to make this a field-friendly unit, they had to do some funny things with variable frequency drive to get that horsepower rating and that speed and the flow. If you don't know, the Grundfos Ready Flow 2, when it's fully wound up, spins at 22,800 RPM. So it's a mover. Both systems have a unique controller. The SSGO sub has a controller. The Ready Flow 2 uses a variable frequency drive. They both convert power, as I mentioned before. The SSGO sub is going to convert to DC. It's going to take an incoming AC power, convert it to DC, single phase power to three phase power. Both offer speed adjustments for flow rate. Things to consider about the Ready Flow 2. It pumps at a greater flow, 0 to almost 8.5 GPM. And it's going to depend on head pressure as to what kind of flow rate you get. And that's true of any pump, not just this particular pump. It can pump from 280 feet, which is a pretty good depth considering it'll fit in a 2-inch well. 2-inch wells offer a lot of limitations to a lot of applications, which we'll cover a little bit further in. These pumps can be dedicated or portable, and there's a whole host of reasons for going one direction or another. Most people will use these portably because they're pretty substantial cost investment to get started with the Ready Flow 2 system. If you go with a portable system with a reel and a VFD, you're looking anywhere from $4,000 to $5,000 investment usually. There's several motor lead and tubing configurations. The motor lead can be round or flat. We have one that we make here that's got an integrated safety cable. If you're doing it portably, you can change out the hose so you can minimize the decon on that portion of it. There is a bonded motor lead and tubing configuration. It makes decon a little bit more involved, but it's a much more portable system, but it adds a little bit of weight. I've sampled, I don't know how many wells with the Ready Flow 2. Some of the deepest wells I did in Idaho were probably approaching 250 feet. And with bonded tubing and motor lead, it's a workout. This pump does have a thermal overload. Most people don't know that. They bury that in the manual. The Ready Flow 2 is very susceptible to overheating. I actually participated in the beta testing of the Ready Flow 2 when they were rolling it out in 1989 at the Grundfos factory in California. And one thing that they couldn't overcome was managing the heat that this pump will generate. So I want you to think about what that means in terms of sample integrity and the longevity of the pump, okay? When the thermal overload triggers, it's actually within the pump itself. It'll send a fault code to the controller. But most of us that are out in the field trying to get work done, the pump stops pumping, what do? We throw the circuit breaker and we start it up again because it shouldn't turn off. Shouldn't. It's a reliable overload, but it's only good for a couple of rounds because if that pump continually gets hot, that thermal overload fails and that pump turns into a paperweight in no time. The GeoSub has a little less of a depth application, but there's a trick, and I'll talk to you about that. It does variable flow rates from 0 to about 4 gallons per minute, again, depending on head pressure. It pumps from 200 feet, but the outer housing on the SSGO sub can be exchanged for what we call a drop tube housing. So as long as the pump is submerged and you need to pump greater than 200 feet, you can relocate the intake to a greater depth, which is a pretty cool option, right? You don't have to do it all the time and just trade it out. You have a standard intake, or you can go with the drop tube intake and relocate that intake. So if 200 is a threshold that you can't You can't work with the SS Geosub with the drop tube as long, again, as the static water table is within 200 feet, you can relocate the intake to a greater depth. It does have a programmable controller. You can actually input particular well parameters in terms of pumping speed. So if you're doing a site routinely, you can actually plug in the well ID number, program it in, and each subsequent visit to the site, particularly if you have dedicated pumps, you just call up that well, push the button, and basically start moving. It's a pretty cool deal. It also offers a dry run feature. Typically, if you're doing a high purge and you're doing other things than monitoring drawdown, you can ask the pump to shut off, which is a pretty cool feature. The flow curves for these pumps are based on motor speed. I don't know if you can see it. The Geosub will deadhead at about 200 feet. That's the curve. But I've seen flow rates greater than 3.5 on shallower applications. It's going to depend largely on the condition of your pump. You know, as a manufacturer, we have to say, here's something that we can stake our name on in terms of flow rate. So we publish that. The Ready Flow 2, much greater depth. Again, you can see it over 250. I've seen it do, and we pressure tested them beyond 280 feet ahead. But that's, again, where it deadheads at 0. This information is found on our website if you have more interest in expectation derailment, spec in for the wrong application. So I mentioned I worked with Grundfos back in 1989. I've managed field crews. I've worked with Geotech for 21 years. I've trained salespeople. I've trained technicians. I've got a lot of hands-on experience. And the one thing that after this many decades of working with this pump is I still get calls from engineers that want to use these pumps for things that they're not designed for. And I had a call just last week. Somebody called up and says, hey, I've got an application. We're working on a landfill. We're looking at the Ready Flow 2. I said, oh, for monitoring and sampling programming. He goes, no, we want to use it for leachate recovery. No, it's not a good choice. These are made for purging and sampling clean groundwater only. And I want to keep re-emphasizing that because it's a thing that comes up so often that it bears repeating. It's not designed for continuous operation. So again, sometimes someone will call in and says, hey, I want to do a aquifer test, or I want to use it for water table depression over time. It's not designed for that. It's for intermittent use. It's for purging and sampling. It's not designed for leachate recovery. It's not designed for remediation. I had somebody say, hey, I want to recover gasoline with the Ready Flow 2 or the Geosub. Don't advise that, but we still get those calls. I mentioned aquifer tests. It's tough enough to do an aquifer test with a large well and a large pump, but in a 2-inch well, it can be done. I would just say buyer beware. If you don't want to buy a pump, you probably will if you use it for that application. Again, it's not made for continuous operation, so those kinds of things will cause the pump to degrade or overheat pretty rapidly. And then the last thing, and I put this one last, is well development. During some of the training sessions I've done with respect to the Ready Flow 2 or even the Geosub is, can I use this pump for well development? My answer is you can, but if you want to accelerate its wear and failure, be prepared for that. We have people that rent pumps for that application, and we try to prepare people that, again, going back to the earlier comments about best use of field time, if you're using these pumps in applications where well development is part of the task, the rapid acceleration of grit and high speed in the mechanical parts will cause a failure. You might get lucky. I've had a couple people return pumps and they were literally full of mud. How they spun, I don't know. But I've seen pumps that have literally turned. Have you ever seen Stainless steel, when you weld it, it gets that cool blue color. I've seen pumps get so hot that they turn blue. So keep that in mind. Some of the components I mentioned earlier that all these pumps require maintenance. They're configured differently. The SSGO sub is a DC motor, but it's not like a DC motor that you would find on a little fan that you buy at the convenience store. It actually has a control module that conditions the power. And you'll notice it goes from 2 wires, and you can't really see it in the photo here, but it goes to 3. This is a very high performance, high speed motor. So that conditioning module is what moderates the power to feed that motor. As an assembly, those 2 items are a wear part. ReadyFlow 2, this is the main wear parts of the ReadyFlow 2. There's a lot of call outs there, and I didn't want to complicate the slide, but in effect, you have components that are duplicated. There's two impeller stacks within the pump housing of this pump. They're very precision. Again, high speed, 22,800 RPM. Any grit gets in there on those Teflon components and they disappear. I've seen impellers worn into the top of the pump because of grit. I've seen impellers worn to where it looks like spokes on a bicycle from pumping grit. And the question is, how come my pump's not working? And it's a question of maintenance. In summary, ReadyFlow 2, higher flow rate, greater depth spec. These pumps, both the SSGO Sub 2 and the ReadyFlow 2, give you continuous flow. Coming back to generators, the small generator for the SSGO Sub, it's very forgiving, very economical to operate. The ReadyFlow 2 is going to require a generator that doesn't have a GFCI. And why that's critical is the GFCI interprets the VFD frequency noise as a short and trips it. So it doesn't matter if you have a 6,000 watt generator or a 2,000 watt generator, if it has a GFCI and you plug a VFD into it, it will not work. It's probably my #1 troubleshooting call. Maintenance is the key to success. These small components, O-rings, Teflon parts, easy to carry around. When I was doing field work, we had a little tackle box. We had Teflon parts, we had motor pins, we had O-rings, we had whatever we needed, kept it in the box with the VFD. If you go to remote places like Idaho or Montana, which I did a lot of work in, next day air is like 4:30 the second day. So you can lose a lot of time. That's a lot of per diem. That's a lot of sitting around. Plan ahead on consumables, tubing, other components that you may need to manage the project, and stick to the design parameters. Don't use these pumps for anything other than purging and sampling. And you'll have a much better experience. And just to kind of sum up all of this, we did a little competition on pump maintenance some years ago because the perception is this is really complicated and it's going to take a lot of time. So I took salespeople who don't necessarily have a lot of hands-on experience, and we said, okay, we're going to do ReadyFlow 2 maintenance and we're going to time it and just see how long it takes. So completely disassembling the pump, completely deconning it and putting it back together. Anybody have a guess? 5 minutes. And that's everybody asking questions and taking time. Once you have the familiarity with the pump, it's a good number to budget 5 minutes, but it's less than that. I'm not going to tell you it's 2 because that's not realistic, but it's not a lot of time. But that investment in time will save time in the field. And if you own the products, it'll also save you a lot of cash and having to replace things prematurely. Does anybody have any questions?
You may have covered it in the beginning. Two of the biggest questions I get is on the controller, what are the, as you step up the pump, what do the numbers actually represent? You may, like I said, you may have covered this in the beginning.
Oh, on the SSGO sub?
Yes, yes.
We're going to call them units.
Right, and that's kind of what I tell people is hey, it's kind of their unit, you know. I don't know if you can relate it to frequency or speed or.
That's a great question. It's a question of starting speed. So I think the default is 100 on the SS Geosub. That is a number that at the factory we have programmed in to say that's a safe start speed to get flow. Now I have a client in Arizona who is pumping from a greater depth. He's got to start at 120.
Okay.
Otherwise he gets an error code, no pump attached. But increasing that speed, he gets a little bit more of a bump and he gets the flow, and then he can manage the flow.
Okay.
Another quick aside, how are we on time, Drew?
You're good.
So another aside, we had USGS has a lot of ready flow twos. They were kind of one of the main clients of Grundfos in developing sampling technology for purging and sampling, and the ready flow 2 is their tool of choice. So here locally in Colorado, we had a USGS office rent a ready flow 2 because they had burned theirs up and they just needed something in a pinch, and they went up Highway 285 up to a ranch up in the plains up there, and they were able to get their work done. But when they brought the equipment back, they said, well, we only got about a half a gallon a minute total at 400 hertz, which is the max hertz rating of the controller and the pump. And I said, well, that's odd. What depth were you? My perception would be that they're at a greater depth. Oh, the water table was only at like 35, 40 feet. And I started asking them questions, and it became a question of technique. So with the Ready Flow 2, it starts off at the bottom end at 25 hertz. And logical human interpretation is I'm going to turn it up very slowly to bring the speed up to get more flow. And what I found over time in lots of troubleshooting calls is with the Ready Flow 2, you got to start high and bring it down low. And I don't know what the physics are in that. Maybe somebody here can offer something on that. But somehow going slowly, there's something that augments the ability of the pump to flow versus starting high and going low. So I would say if you're in the field and you want to maximize, optimize flow for low flow sampling or purging and sampling, start off with something higher than you will actually pump at and reduce it to a rate before you connect your equipment.
Question came in. Are you finished that?
Yeah, I'm good. Go ahead.
So the question came in, based on those flow curves that you've shown earlier, are those based on pump location or is that static?
It's going to be based on total dynamic head, which is a function of where the static water table is in relation to the pump depth. With electric submersible pumps, your pumping head is the water table elevation because you're having an equilibration of water within the tube, regardless of how deep the pump is set. So if you have a water table at 100 feet and you set the pump at 150 feet, you're pumping at 100 feet until that water table starts to drop. And how that differs from a bladder pump is in a bladder pump, the water that fills the pump is then isolated in the bladder, and the pumping head is the tubing length, regardless of the water table. It's kind of hard to wrap your noodle around it if you're talking about it, but when you see it, water fills a bladder pump, the water's isolated, you're applying pressure to get the water out. With an electric submersible, you got a little bit more latitude. Go ahead.
Another question, you mentioned the pumps can be used, you talked about the pumps being used for purging sampling, and they also be used for local sampling.
Yes. Both of these pumps have enough range in their speed control that you can turn the flow rate down to 10 or 20 milliliters a minute. Most people don't sample at that low of a rate. The SS Geosub 2 is so sensitive that if I were to hold the discharge tube at waist height and simply raise it to elbow height, that small difference in pumping head will augment the flow. And the reason I bring that up is sometimes you'll try to make the adjustments on the controls to say, gosh, it's too much or it's too little, and you're in that vast middle. Sometimes just changing the elevation on the discharge line will give you the flow rate that you need. It's a little field hack. Anybody else?
I do have a second question, is being that it's bottom fed versus the RF2, which is more of a top fed, you know, we get a lot of silt out in the Sacramento Valley.
Okay.
And so I was just curious the delicacy compared to an RF2, you know?
It's a fantastic question.
Because we all know, if anybody's dealt with an RF2, how delicate they are, and you get the drillers that come through and you go, oh, I can't rent this to you. Probably gonna have to sell it to you if this is what you're gonna use it for.
So again, going to the grit accelerating wear on the pump. Standard practice in any of the manuals will tell you to keep the pump at least 3 feet off the bottom. Sometimes that's not possible. So it becomes a question of turbulence, turbidity, and just managing flow. Even at the slower flow rates, the abrasion is going to accelerate wear. So whether you're 400 hertz on a ready flow 2 or 25, if you're pumping grit, you're sanding things down. SS Geo sub, same thing. There's some real tight tolerances. That outer housing on the SS Geo sub, when you remove it, it exposes the impeller on it at the bottom. Now that impeller is fitted within that outer housing. There's a small orifice that we've designed that helps create pressure. So again, you have motor speed, but you also need pressure. Ready Flow 2 does it with speed and these 2 little impeller stacks. The SS Geo sub only has a single impeller, but it's using, we'll call it magic for lack of a better term. It's using a small orifice within that outer housing to create the pressure. And something to elaborate on your question, to dissipate heat in 4-inch or larger wells with a Ready Flow 2, you must use a cooling shroud. And in wells where you have high sediment loads, that cooling shroud in effect relocates the intake to the bottom of the pump, and it becomes a vacuum cleaner. So if there's sediment and you have the pump beyond 3 feet above the bottom of the well, it's going to vacuum sand, silt, whatever is moving through that casing and that formation. The SS Geo sub, we designed the outer housing to be a cooling shroud. So there's no external parts. The water flows around the body of the motor by design. And in a 2-inch well, the Ready Flow 2 does the same thing. Okay. The reason the heat is such a problem in larger wells, if you have a high yield aquifer, let's say it's a 4-inch well, the intake of the Ready Flow 2 is near the top. That water is just mainlining in and going up and not necessarily moving over the body of the motor. That cooling shroud helps facilitate that dissipation of heat by moving the water deliberately across the motor itself. Does that help?
Yep, absolutely.
Okay.
Thank you.
We on the next one?
Just wanted to key you up. Yeah, it's about that time. Whenever you're ready.
Wow. Okay. All right. Thank you for that. If you're staying for this one, I'll give you a minute.
Thank you, John.
Thank you, man. Glad to hear it.
So when's the next starting?
1 minute. We've got these back to back. It's good.
No, just.
So give about 90 seconds in case somebody else shows up. How's everybody doing? Doing good? Good.
Doing great, man. How are you?
Thanks, man. I'm doing well. Yep, glad you could make it. I'm giving about 1 more minute, Drew, just in case somebody wanders in. That clock on that wall right there, we gotta throw it away and get a battery for it.
Oh, yeah.
I keep looking at that going, God, how am I that off on time? Cool. All right, well, I guess we'll get started. There's probably some people logged in online. Respectful of their time as well. Thanks for coming. We're going to talk about economical sampling systems. Basically, we're going to cover today everybody's favorite balers and a product we make. It's a disposable pump called the Geosquirt. Geosquirt is a 12-volt perch pump, and it is disposable by design. And we'll get into how this is a time saver and an economical way of purging wells. Baler is the most common and reliable sampling tool. Does anybody disagree with that? It's predictably awesome. Everybody loves baling wells. It's cost effective, but it's a little bit time consuming. It's an excellent fail-safe to other sampling equipment, but it may not necessarily be optimal for VOC sampling. And what I mean by fail-safe is, again, managing field crews. I always wanted my people to be productive, and if they're mobilizing, flying, driving, whatever the case may be, having the means to complete the work is important. A baler is something that's very portable and easy to have on hand should you need it, and hopefully you don't. There's a lot of attachments to enhance your baling experience. We do offer VOC tips up here on the left-hand corner. These tubes here are bottom emptying devices to help channel and moderate the flow out of the bottom of the baler. And this little scoopy device here is a product sampler. Now, product sampler, people say, what's that? Product, hydrocarbons particularly, generally have a specific gravity less than 1. That's why they float, right? When using a baler to get a product profile, the weight of the ball in the bottom of the baler isn't necessarily displaced at the surface of the product layer because of the difference in specific gravity. So if you have a thick product layer, you'll be able to get product somewhere in that column due to hydrostatic pressure. The product sampler captures a scoop of product on its way down to assure that you have enough mass, if you will, to displace the check ball and actually give you a visible and representative profile of product. So it's disposable, it goes on the disposable baler. It's a cool little adder if you have those kind of projects. The baler as a sampling tool, technique is everything for sample competence. Deployment, retrieval, sample collection. There's a lot of white paper work on balers. It's a baler, but there is technique. It's pretty important. There are trade-offs to other sampling methods. Your hands are always occupied. You can't do anything else other than bale if you're baling. And bird's nests, everybody's favorite thing. Somehow or another, you miss a loop with your thumb, it gets wound up, and you end up with this knotted ball of string and a baler full of fluid and a little bit of frustration. I don't mean to dog on balers. They're very, very good tool. The point I'm trying to make is as a sampling technique, if you're using a pump, like we were talking about in the earlier session, you get a continuous flow or an intermittent flow. You can manage well stabilization or volume, and you can fill out sample forms and and labels or whatever it is you're working on in your field book while that activity is going on. With the baler, you're 100% focused on baling. There are a variety of balers for any application. We've got short ones, long ones, fat ones, skinny ones, poly ones, PVC ones, Teflon. Depending on the application, the sampling protocol, whatever your sampling and analysis plan calls for, there's probably a baler to fit that need. If you're doing small diameter direct push wells, 3/4 inch or 1 inch, there's a baler for that. If you're hogging water out because you got no other alternatives, there's a 3-inch baler that'll pull out about 1.5 gallons of bale. It's a lot of weight, it's a lot of work, right? It's good for the cardio. But I just want to put this up there for illustrative purposes that you can see some of the volumes based on baler length and diameter. It's a math problem. If you've got to purge 3 casing volumes, you can pretty much work out in your head how many bales you got to do. We even have fancy tools for making things easier, but it's still going to require the total occupying of your activity with your hands. We can fit these with, I've seen one go out with 2,000 feet of cable. Deepest I've ever baled was 655 feet. Don't recommend it, but it can be done. This tool is the same real electric rewind that we use on our longer length water level meters, like 1,500 feet and above. But in a baling application for something that's a liter, 1.5 liters, it's a good tool for that. If you're not familiar with the GeoSquirt, it's a good little tool. For us, it's just a handy device. One of the companies, consultants I worked with, had a GeoSquirt on a hose reel with tubing. We were doing nothing but inorganic sampling. We would purge with the GeoSquirt, pull out a nice fresh baler, drop it down, capture our sample, and move on. So it's kind of a time saver. It's disposable by design. It's a little plastic PVC 12 volt. There's nothing serviceable on it except to replace it. So if you turn it on and it works and you pump some water and you find that you've been pumping a little bit of grit and something internally in the seal fails, just use another one. We do offer 3 depth rated configurations, a 30-foot unit, 60 and 90. It's typically not used for sampling. Again, it becomes a sampling and analysis plan question as it relates to materials of construction and what you're sampling for. We had a client that insisted on dedicating GeoSquirts for sampling, and we advised them to no end not to do it because the pump won't last and it's not designed for that application. So just like in the previous conversation we had on the previous presentation, being mindful of what these things are designed for is a key to success. Well, they insisted, they dedicated GeoSquirts for sampling. Andrew knows what I'm talking about.
What's that?
Dedicated GeoSquirts.
Oh, yeah.
And after the first sampling event, everybody was happy. The second sampling event, they didn't work. And they were upset that they didn't work, and we said that's not what they're designed for. And it's a problem because as a manufacturer, we want to represent products to the people that use this stuff in the field in as fair and accurate a way as we can. I spend a lot of time in these talks making sure people understand that we can only say what they're designed for, and how people use them in the field is a completely different thing. But we want to set you up for success because quite literally, the success of our clients is our success. And it's a pretty easy one-to-one correlation if it doesn't go right. These are for purging groundwater only, and we do offer external pump controls. This is just an image of the three pump lengths. The 30 footer is a single, the 60 footer is a double, and the 90 footer is a triple. And what that means is we take that little small pump there and we bridge it together in 2 or 3 configurations to get the greater pumping pressure, like we talked about in the previous session, to overcome that pumping head at a greater depth. Now, with more pumps comes more energy requirement. And just a little side note, if you have a 12-volt battery, which these things run on 12 volts, for every 30 feet of motor lead, you lose 1 volt. So if you're looking for optimal pump performance, the longer the lead, and this is true not just of the GeoSquirt, but there's motor lead specifications for every pump based on motor horsepower and length. So this applies to this as well. Just keep that in mind. The different flow curves. Yellow is the single, blue is the double, and red is the triple. At 0 feet ahead, you're over 2 GPM, but just barely. And as you move up in pumping head, that trails off pretty quickly. The controller options we have, we call them the Buck controller. We had an employee in our Texas office, last name was Buck with 2 U's. He says, we need one of them fancy controllers where you just turn the knob. So we put the instructions on there and it says, just turn the knob. Gotta have a little bit of fun with it. We enhanced the Buck controller to add a couple of timers. The GeoSquirt can only be run a maximum length of time of 15 minutes before it needs about a 5-minute cool down period, right? So as a manufacturer, we say this is going to give you optimal pump performance. So we built that parameter into this controller, but gave some latitude in how many minutes you want it on and how many minutes you want it off. It's a cool feature, right? If you're purging 3 casing volumes and you got a 2-inch well and your water column is 10 feet, you got 0.163 gallons per foot. So you got 1.6 gallons per casing volume. You can figure out the flow rate, set this up, and probably purge the well in a very short order, depending on the pumping head. And that frees up your hands to do other things. Since you're not going to sample with the GeoSquirt, you can use a fresh baler, use proper technique, grab the sample and move on. So it's just kind of a time optimization tool, if nothing else. Motor speed adjusts flow. You can manage purge rates for low stabilization. You can hook up the GeoSquirt to a flow cell. If you're monitoring your standard parameters, it's a good way to do that. And again, allows you to do other things while you're pumping on the well. The GeoSquirt in conjunction with balers, use one to purge, one to sample, frees up your hands to do other things. Well stabilization allows for focus on baler technique for proper sample collection. In summary, these are ultra portable, individually or as a combo. It's a low cost alternative, great for initial site investigations and sampling events. It's an excellent backup system to optimize the time. And if you're into upper body strength training and cardio, you can. And a little side note, we manufacture balers in this facility. If you haven't taken the tour to go look at our baler cell, we actually have work cells for different products we manufacture. We'll show you how we put them together. We do a biodegradable additive for our polyethylene balers. As an environmental company, we want to try to do what we can to provide a durable, cost-effective, and at least environmentally conscious product. And I believe that's all we got for that. So questions? Yeah.
Biggest question on the balers, and I haven't found anybody that offers them, is a PFAS-free certification.
So hold that thought.
Okay.
Everybody dealing with PFAS applications? Not so much, some? Okay, so to my understanding, there are more hard and fast rules with each passing week, it seems. But I think there is still an umbrella of materials, or under an umbrella, there is a list of materials that are acceptable for that application. The balers are made of high density polyethylene.
There you go, okay.
So even though we don't send them for a lab for PFAS certification, they do fall under that umbrella for that sampling application.
Okay. That's number one, is the fact that they are HDPE. That kind of clears the table on that one, so.
Yeah, that's a question. If you're not dealing with it, you're gonna find more and more of that. It's typically federal sites, but it seems like everybody's getting involved at some level.
Yeah.
It is the new contaminant of concern in this era, and rightfully so. It's got a lot of.
It's a headache though.
Yeah. So we do offer, on the PFAS subject, we do offer a PFAS-free certified bladder pump.
Right.
And we do make a water level meter with PFAS-free components.
Oh.
HDPE, things of that nature. So we are trying to respond to that demand, but because it's still kind of a lot of gray areas, we don't want to put the cart before the horse, so to speak, and start making stuff and buying inventory to find out that that doesn't work anymore.
Okay.
Which is entirely possible. Any questions in the back group?
No, I don't see any here. Just to comment on that, we do have a presentation that's really 11:30 to 12.
Okay.
Touch on PFAS and some of the equipment.
I think it's good practice for everybody to bail a well, honestly. It provides a perspective in how the well's constructed, the water quality of the water being removed from the well. As a well development tool, balers are pretty reliable and they are disposable. We do offer reusable balers. We have stainless steel, we have PVC, we have clear, we have opaque. I mean, there's a lot of options with baling. It's not glorious work, but it is honest work. Reconditioning a well, baler's a great tool for that. If you're gonna put a pump in a well and it's recently drilled or hasn't been touched in a while, a baler is a great way to clean it out to some degree before putting a pump in. You got a question, Drew?
Do you want to touch on the independent lab analysis that's done on that equipment as well?
Sure, and we gotta get together on that. So one of the things Geotech decided to do about, it's probably been about 14 years ago now. We had a client that wanted some assurance that the materials we use in our baler were clean. So we extrude tubing for tubing and we extrude tubing for balers. And we injection mold HDPE for the baler components. I think the only thing that we don't manufacture is the ball, which is a PVC ball. So what we decided to do is, off the production line and out of inventory, take a collection of pieces and parts and cuts of tubing, send them to an analytical lab. They'll do a sterile bath process in the lab, sample that bath water that those components are in, and analyze for VOCs, SVOCs, and metals. And without fail, we've been clean all of the time. We had one hit on copper that was outside of the detection limit range that we expected. And we think there might have been something on the extrusion tool that was exhibiting some wear. But what we did is we say, hey, here's our certification. It's on our website. We had a hit on copper. And we sample semi-annually, routinely, sometimes quarterly, but mostly semi-annually. And we run enough inventory in lots that we can say once it's manufactured into a product, and sealed. It's clean, and you're not going to get anything from the stuff that we make. That's kind of our commitment to the industry, and it's something I don't think a lot of manufacturers do. There's not a lot of environmental equipment manufacturers, and of the ones that do exist, there's us and maybe one or two other companies in America, and a few companies in Canada, and a few companies in the UK. There's not a lot of people making this stuff. And Geotech has succeeded by trying to be upfront with what we make, that you're buying a solid product, try to stand behind it, help people by training them for use, providing this opportunity at field days to get people in to see the people that are representing the product, making the product, the people that make things for us in terms of instrumentation and their commitment to Geotech and to you, the people that are using the equipment. So we're a family-owned business. We try to bring everybody together. Clients and manufacturers like to say, here's what we're trying to do to be in front of this. But the feedback we get, we're an ISO 9001 2015 company, so customer feedback is very important. And we take that feedback to our production process and our engineering team to say, is there a trend like PFAS, right? Is this something we need to get ahead of? What are the rules? What are we trying to accomplish? Sometimes we find out we made a pump 15 years ago. We were pretty proud of it, but it had almost no input from anybody that actually uses the equipment. And we tried it and we scrapped it in about 4 months. Nobody would sell it because the phone call was always the same. I'm going to strangle you with this thing. So the feedback wasn't positive, but we didn't try to oversell something that's not going to work. We take that feedback and try to make things better. Each incarnation of our bladder pump, Geosub, whatever it may be, we're always trying to implement the newest scalable technology into something that we can manufacture. Our equipment isn't necessarily the fanciest, but it's probably the most durable in the marketplace because it's field equipment. We want things to last. You got a question, Drew?
I was just gonna say, we have a couple minutes until we transition. If you want to address those who are joining us virtually, maybe see if they have any questions.
Okay. Anybody have any questions? No? Anybody learn anything from this or the other presentation? Just a little bit? Yeah. You know, for anybody that's been in the industry more than 6 months, you probably touched it earlier. It's probably a good rehash on that. The pump systems, I see a lot of faces over here for that. Hopefully there's a takeaway in that. Billable times key, useful billable times even better. And great data is what keeps everything moving. So having the right technique, whether it's a baler or a pump, being able to be productive in the field, be prepared in the field, have alternative measures for getting the job done. That's kind of the goal of my presentations, to try to take that into account. So, cool. Appreciate everybody's time. Thanks for coming.
Sorry, what's that?
You see the slideshow well now?
Yep, slideshow is on there.
I think one thing
I think you froze, but it looks good on our end.
Yeah, you know, I can see it here. Yeah.
You've been sitting in all the presentations today, Frank?
I think I missed the first hour and then kind of popping in and out. We were particularly interested in the Geosub pump and what might be available for troubleshooting. We're still getting a lot of failures in the field with the connections getting wet. And I think Andrew's going to contact you and talk about options for us.
I missed a lot of that. It keeps cutting in and out, but I heard Geosub failure. Need to talk about it.
Yeah. Andrew will contact you about it.
Okay, that sounds good.
Yeah. I'll be able to do this afternoon. Will you be around now? Yeah, I'll be around. Just catch up around 4 o'clock. Kind of right at the end of the sessions. We'll get some comments on the rest. Did you? We were only back to
Morning.
Morning, how are you?
I'm doing well, yourself?
Good.
William, where do you work at?
Nationwide,
Okay.
pretty much, manage Superfund sites, the ongoing O&M.
Okay. Nice.
So we run all the monitoring programs.
How long have you been doing environmental work?
76.
Yeah. Thanks for coming.
We usually make it every year.
Nice.
Not last year, though.
No, unfortunately not. So nice things are starting to open back up though, huh?
Oh, yeah. Yeah, still a lot of strain on a lot of the programs. Travel.
Guys getting back out there, getting those systems working again though?
Yeah.
Yeah. You guys use any composite samplers?
Yeah, we use them for the outfall.
Yeah. What do you think of ours?
Well, we haven't used yours, but came to give a listen.
What's that?
I thought I came to give a listen.
Yeah, yeah. Almost 11. Hello. Right, well, it's 11, so I'll get going. Thanks for coming, guys. I'm Brian at Geotech. I'm going to speak a little bit on composite samplers and our unit. Some benefits of composite sampling in general, the product development, which led to us having a unit, the functionality of our composite sampler, the components that we send in the kit, and a couple applications it could be used for. So anybody that doesn't know, a composite sample, we're collecting a portion of that at some time-based interval. That may be hourly, half an hour, something like that. Some benefits of using any auto sampler: you could be less likely to miss parameter changes. You could save some time, staff could be more productive completing other tasks, and it could also be a safer method for collecting a sample. So parameter changes, if you're sampling right here, you're going to miss that. So if you're collecting a portion of your sample every hour, every half an hour, you may be more likely to see something like that that's going to be a spike. Time. An alternative to an automated sampler would be sending somebody out to collect samples manually with something like this. So if they're doing that very often, that could take up quite a bit of their day. Related to stormwater events, if you're sending somebody out to collect samples in something like this, that could be potentially hazardous versus setting up a sampler, going to deploy it, and then coming back the next day or sometime in the future. So why did we make one of these? Well, we have a voice of the customer system here. Jeff was mentioning it a little bit in the previous presentation. to change products or develop new products. So in this case, we had some distributors as well as end users contacting us, asking for existing manufacturers' units. Some of them are ISCO, Global, YSI makes one. Well, everybody was getting these units to sample wastewater for early detection of COVID-19 before people would be symptomatic. So we looked at existing components and we were able to take our geopump, put some timers on it, and make a flow and put this thing together. So how auto samplers work, peristaltic pump, positive displacement, found a good graphic online. So generally there's going to be an electric motor connected to a pump head. So this would be the pump head to spin it. So this is our unit. As you can see, we're using the same geopump housing. I'm sure a lot of you guys have used these before. Instead of the dials for speed, on, off, and direction, we've got a tank full. Talk about that in a minute. An indicator light, on, off, and some controls here. So when you deploy these, for example, if you wanted to collect a portion of your sample at an hourly interval, this is where you would set that. The sample time is how long the unit's going to pump each interval, and then the start delay. So you configure this, you put it in the cooler, in our case, right? You may need a little bit of time to get it deployed before it starts collecting a sample, or it's not going to be in the water yet. So that's what the start delay is. The sample time, we have a chart here to get you a ballpark number, and then you'd want to ideally run it with a graduated cylinder. Make sure that you're getting exactly 400 milliliters if that's what you're looking for. This unit also back flushes too, so it'll run for 20 seconds if you had this set to 20 seconds. And then it would run 20 seconds in reverse to flush the line so you're not collecting stagnant water in the line. So this was really the only piece that we had to kind of make from scratch, but we make floats for remediation systems. So we came up with this guy to tie into the bottle. So if your timers are a little bit off and you're collecting 420 milliliters per cycle, it's not going to overflow the container. Components of our unit. So we found some off-the-shelf 2.6 gallon containers. Our standard DC battery is powering this. The intake screen is from one of our bladder pumps, our 0.85 inch bladder pump. So that was another piece that we already had off the shelf. We just had to swap the hose bar. HDPE tubing for going down well or getting the intake into your sampling location. And then igloo coolers. These were really easy to find because there was no sporting events. So we were able to source these without issue. So we developed this economical option. We were able to support some of the demand in the market for these wastewater samplers specifically. A list of the components that would come in our standard kit, which I just described them all. Any questions so far? No. Optional accessories, suspension harness, we would sell that separately. So if they want to place it in a manhole, hang it from the cover, then we'd have a harness and a bar basically to achieve that. If they want to use it in a facility, we could use an AC power converter. It's the same one that we use for our peristaltic pump. Plug it right into a wall. We also made a part number for a wet kit. So if it's pretty dirty conditions, you need another 100 feet of suction hose, 5 feet of silicone, maybe one of those stainless steel intakes getting fouled up or deteriorating. So some applications that these could be used in, surface water monitoring, wastewater, wastewater effluent, industrial process monitoring, storm event, or anywhere else that you want to automatically collect a sample. Is anybody using these for other applications?
What about, you mentioned the COVID-19 detection. What was that about? How was this used for
Yeah, so these are being used for wastewater. They're putting them in the sewer basically to sample for COVID-19. COVID-19 is present in feces. So this will give earlier detection versus waiting until someone is symptomatic and having them go get a test. People could quarantine earlier or go get tested earlier. Other questions? No? I threw a couple links in here to the EPA documentation talking about automatic samplers being used for surface water monitoring, as well as wastewater. This is the EPA procedure stating you could use it. I feel like I kind of ran through that quick. Talked about some benefits, product development, the functionality of our units. Questions, comments? Do you guys think this is a good economical solution to what's already out there?
Could you go back to the slide with the Senate?
This one?
Yeah.
Okay. So the length of time that it needs to be on is going to be dependent on how long the tubing is and how much sample volume you want to collect. So for example, if we wanted to get 500 milliliters and we had 10 feet of tubing, we'd have to put that to 37 seconds. Again, you'd use this as a ballpark to get you close to where you need to be, and then ideally use a graduated cylinder, run the pump to fine tune the dial to exactly what time you need it.
What size bottles are you looking at?
2.6 gallon containers.
So you kind of calculate if you're doing a 24-hour composite, you want to collect samples every hour.
Correct, so that'd be 396, 400 milliliters. There's other questions, comments?
Does the line purge only happen after you've collected the sample? Or can you program it to take up a sample almost to the bottle and purge it, and then take a sample?
So you're asking if it purges it after every sample collection?
Yeah,
It does.
and then that doesn't re-purge to, before you collect the next sample, right?
No, it back flushes after it collects a sample, and then it will just turn on the next hour.
And I think the line is pitched, it doesn't allow any production in the tubing. Maybe something to consider.
What about other ones that you've used? Do they do a back flush prior to starting a second?
Most of them do it the way your system does it, but if you're dealing with some sensitive low concentration parameters, you may want to purge the line before you take the next sample.
Sure.
To get more representative sample, but I don't think it really matters that much.
We could program it to do that.
That's what I'm asking.
Yeah, we could absolutely do that.
Especially when you're dealing with PFAS, which is in the parts per billion, range. You really want to make sure you're actually sampling the next representative sample.
Yeah. Are you using composite samplers to sample for PFAS?
Not yet.
No? Sounds like you want to though, huh?
I'd like to.
Well, we can make some that have that extra backflush for you if you'd like. How many you want? No, I'm just kidding. Yeah, I touched on that too. I didn't have a good photo, but we do have the option for a suspension harness. So that'd basically be a net that goes around this, going up to a bar that would hang it from the manhole.
Is the bar adjustable?
Yeah, so the kit that we have, we're sending it out with 25 feet of cable, and you can adjust the safety cable to whatever depth you want it.
No, I'm talking about the bar that suspends it,
Yeah, so the bars,
because manholes are different sizes.
yes, correct. So the bar is adjustable as well.
So if you have to use both of the 2.6 gallon bottles, do you have to calculate manually how long it's gonna take for one to fill up and then switch the floater over to the other bottle?
Correct, yeah. So you can only attach one container at a time. We send it out with two for kind of a piggybacking, right? So you deploy it. Once it's full, go out there, swap out the bottle. So you can't run both containers simultaneously. Do you have a need to do both simultaneously?
Yeah, so for our 24-hour composites, we need at least 4 gallons of sample. So we have to come out and switch the bottles out.
Sure. We could find a larger vessel for you. What kind of application are you working on?
I work at a surface metals mine, and we do the full effluent toxicity testing.
Okay.
So they require composite samples.
So you're just setting this up, coming back every day, or how often?
Just once a quarter.
Once a quarter? Yeah, we could definitely get some larger containers for it.
And are the containers just PVC, or do you have different options?
We're just doing HD or LDPE bottles right now.
LDPE?
Yeah. You would probably need HDPE though, huh?
Mhm.
Yeah. We can find some. Drew, do you remember what size opening that is? What type of
We
opening?
have a lot of configuration options for this auto sampler. This is our initial launch, just in response to COVID-19 community micro, Brian was saying, micro detection. But we expect this product to evolve into a discrete sampling, multiple bottles, as well as different raw materials, glass, HDPE, various sizes as well. So this kind of feedback and just understanding kind of where the needs really are to help us to be able to evolve this system.
Yeah.
Refrigeration, we've got requests for electric refrigeration, 115 volt. So that's something that may come into the next generation. This particular one is just iced, or ice packed, which is sufficient for what it is intended to be used for. Yeah, next versions are going to be good, so your feedback is definitely even with Brian or something later on.
Seems like easy swap outs, different material, bigger bottle.
Yep. No question.
Yeah.
Do you guys have plans to make this sort of like a remote, sort of like this way, for instance? So I do a lot of like Wi-Fi or something, and so if there's Wi-Fi and I have a system like this in my field, obviously I don't have the time to go there, but having some setup like this to stop it out, where I can just do it on my phone or something like that, that would be very, very awesome.
Sure.
So I was wondering if you have plans to sort of incorporate that.
We could definitely do that as well. The board that we're using in here is the board from our solar shipper petroleum recovery system. And we have the capability to communicate via cellular network to that. We just haven't had anybody ask for it yet.
So, that's the thing, because like, for instance, a sample in a very remote location where there's no sort of connection. So, is there another way that you think that we can make this work across several connection? Because I know they have those microchips, now you can just connect to like those microchips, like put in like SD cards.
Yeah.
Yeah, you put in for something about the order and just, you know, pay like a monthly fee and or
Yeah, so our Site Pro can communicate via radio, cellular, satellite. Do you want to tell it when to sample?
yeah.
Yeah. I think that we could accomplish it without cellular communication.
I think that would be awesome.
Okay, good question.
I have one other question.
Yeah.
So if you're in an ephemeral drainage and you put the tubing in there, is there some way to have the sampler start the sequence when it detects water?
Like an ISCO, right?
Right.
So the board has it. We can do it, but we didn't draw the logic up for it. But we could tie in a 4 to 20 milliamp signal or just another float. So when it's conductivity sensor.
Right. That might be something you might want to consider, because I can see that as a stormwater application, that's probably the most valuable thing you have, because you don't want it sitting out there collecting the air, you know, so you want it to turn on when water starts flowing and then sample throughout the event.
Sure.
You'd have to kind of guess at the length of the event, but that's better than what we have.
Yeah. That was definitely our 2.0 target for this, is having the inputs like other manufacturers do to have a pressure transducer, conductance sensor tell it, all right, take the sample now.
Yeah. Would be an easy application, I would think.
Good feedback though, appreciate it. Other questions? Any questions on the chat? No?
No, we can unmute them.
Jim, how many field days have you attended now?
Oh, I don't know.
I know it's been at least the last few years.
That's a few of them. I try to attend at least one day.
That's great. That's great. So we'll go ahead and get started. My name's Andrew Lindeman. I'm with Geotech Environmental Equipment. I've been with the company for about 20 years. I started off in production, where I was actually manufacturing a lot of the products that we offer. I also got into rental and repair, where I was servicing a lot of our downwell remediation systems. So we'd get these remediation systems in that were just caked with who knows what, and had to put on all my hazmat gear and decontaminate it, and then begin to investigate why things weren't working. And then I moved into a national sales manager role, basically working with clients to identify what their sampling analysis plans are, helping them develop those with equipment and technology that is right for their application. And kind of a consultative approach. Obviously, we're not boots on the ground, so we're really relying on the information and data from our clients to accurately position the right tools for the job. And then we acquired a company called Leptron Unmanned Aircraft Systems, or drones. And so I kind of transitioned into a business development role to integrate unmanned aircraft systems into the environmental industry. We're all collecting data. Data is really, really important. And so the unmanned aircraft systems were a good addition to our product line because they're also just to collect data. And so we began not only selling aircraft, but then providing aerial services and mapping to create contours and volumetric measurements, etc. So now I'm focusing also on marketing for the company as well. So my role is to get voice of customer, understand what our customers need. Where can we improve our existing products, right? Or do we need to develop a brand new product to meet those gaps in the field, to collect and gather data? Or I'll go out and seek vendors who are already manufacturing the technology, bring those products on board, create literature and information that our team can use to support the product, and then provide organizational training on application and the technology itself, so that our team can provide you guys best-in-class service is really my goal. So today I'm going to be talking about PFAS. I know this topic is really a hot topic at this time, and there's a lot of different angles coming from it. But I'm going to kind of give you more of a manufacturer's point of view as to how we're seeing this emerging contaminant and how we're kind of migrating with it as well. So we'll just talk about PFAS. We're just going to cover it really briefly so we all agree what it is before we move into kind of Geotech's response and continuous response to PFAS monitoring and sampling and mitigation. And then we'll go through a summary here. So about PFAS, we understand that it's a very strong synthetic bond, right? Especially when it's in solid form. So it comes in liquid forms, it comes in gaseous forms, and it comes in solid forms. In that solid form, it's a very strong bond. It's used for non-stick. It's used in a lot of different products of automotive, etc. We can all agree that it's inert, non-stick, which makes it really good for environmental products. We're going into really contaminated environments and applications. We really want our products to hold up. This is a great product to put into our products to ensure longevity. And then, for the most part, there's a fluorine element to any PFAS compound, right? And so there's over 5,000 unique compounds. So if we're talking PFAS, it's the parent of 5,000 subcategories of other compounds. So we get that mixed up every once in a while when we're communicating with the industry. Somebody will say, hey, I need it to be PFAS free. Well, that's different than being PFOA free or any other compound FEP free, right? PFAS is a very specific compound, so we can guarantee that we don't have PFAS in our products, but that doesn't eliminate the other 4,000, 5,000 plus other compounds that you may be monitoring for. So here's kind of a neat chart we picked up early on, and I continue to use it in conversation pieces because it, again, circles back around on what PFAS is. It's a category, and then you have your subcategories of multiple PFAS compounds. The ones that are listed in red here are those that, it says across the bottom, that have been restricted under national, regional, global, regulatory, and voluntary frameworks. These are also probably the most studied compounds out of that entire list. There's white papers, people have studied them, they understand them. But what we have down here at the bottom are the fluoropolymers that we're putting into our products. So these are not under the red list, all right? They're also not very well studied because we just know what they do and what they're capable of doing. And they also don't transport because we know it's a very strong bond. Nothing breaks it down. It's resistant to heat, hydrocarbons, leachate. I mean, whatever we throw at it, it holds up really, really well. So we know that it's not going to fall apart or potentially contaminate or affect the environment. So it can break down to a certain extent, but for the most part, it's really designed to be held together. So check on learning. So if we look at common materials that we're using in our products or within this industry, the first one is FEP, right? And it's an acronym for some sort of compound, chemical compound. But what is it, and does it have PFAS in it? Anybody have a guess? Does that have a PFAS compound in it? Have some nods? Maybe, okay. What about TLPE? It's another acronym. It's an acronym that's deep. Because now we have Teflon lined polyethylene, so we have multiple compounds that are kind of blended together. And then we have HDPE, which we've discussed already, which is an accepted material for PFAS sampling, right? We have Tefzel. What the heck is Tefzel? And does it have a PFAS compound to it? I don't know, maybe, yeah. And Viton. So FEP we use in a lot of our tubing. We use it in a lot of our pump systems. All right, Teflon lined polyethylene is a material. It's polyethylene with a Teflon lining on the inside of it. HDPE, common material in a lot of different products, including tubing. And then with Tefzel is a coating over some of our motor leads or cabling. All right, and then Viton is a common material that's used like in O-rings, for example. or some tubing materials are also made of Viton. So how do we know whether or not these have PFAS in them? All right, well, I always just use Google. There's not a big science behind it. So I'll put in Viton chemical structure, right? And it immediately tells me the main grades are blah, 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 which has fluorine content. Well, based on what we know, if it has fluorine in it, chances are it's one of those 5,000 PFAS compounds. All right, so we're picking up F here, and some of these acronyms are chemical makeup. Fluorine is listed multiple times in different concentrations, so there's some sort of PFAS compound in it. So if you're really truly looking at PFAS free, and you have a material like Tefzel, right? Sure, it has an F in it, but is that a trademark name, registered name? What is that? Well, we can actually look up Tefzel and determine what it's made up of. So Geotech's response to common PFAS materials used in environmental products. So FEP, like I mentioned, all right, it is a compound. These materials here could be made of FEP. PTFE is another common product that we have put in our products. Tefzel or ETFE, right? But what we've done is we began moving these compounds from a lot of our products in response to having to be PFAS free, all right? I would argue that because these are very strong synthetic bonds that they won't break up or impact your sample, even if you're monitoring in parts per trillion range. I'm not the EPA, I'm not creating guidelines, I'm not the regulatory agency, and so we just have to kind of follow, again, what our industry is requesting. And if they say it has to be completely PFAS free, it's almost like, hey, I can't eat food anymore because I'm just allergic to everything. Right? There's tons of different categories, but that's okay. Let's take that conservative approach. Let's eliminate everything, and let's begin removing PFAS compounds from our products. The challenge was, we have an engineer here in the back. Joe, sorry for calling you out, but his challenge was going, okay, well, if we're going to remove this really great material that's good for a lot of different environments, what are we going to replace it with, right? We don't want to degrade the quality of our product. We still have to maintain that quality, but it still has to perform, and it cannot leach any sort of PFAS compounds into samples that are being collected. So we did want to reduce the dependency of PFAS. We can get rid of it in certain products. Let's stop using it. Bioaccumulates in our offspring. So let's stop using it as much as possible. And so we wanted to reduce our dependency on it. Obviously, for the sake of those who are using our products to collect environmental samples or fearful of adding PFAS compounds to the environment, we wanted to avoid those false positives and just minimize the effect of those compounds. But then we also want to maintain longevity and quality of our products, and that's where it comes into finding alternative materials. So instead of like Viton O-rings, we found this material called Buna-N. It's great. Hopefully there's not any long-term side effects to this 30 years down the road that we're going to learn about, but for now, it's accepted, so we're going to use it. What was that, Jim?
I said probably will.
Yeah, you know, they're going to be monitoring in part quadrillion, you know. So anyways, we, you know, Buna-N materials, we've replaced like some of the sleeves on the insides of our bladder pumps with an HDPE sleeve. We've removed the Teflon tape, which is great for keeping things sealed up in threads. Now we're using a PFAS-free proprietary saran wrap, so works out really well. It's not really saran wrap, but it's very similar to it. $15 a roll, if anybody's interested. I'm just kidding. So we began kind of merging those products. And so if you're familiar with any of our existing products, you may see these material changes. It could be the color of the material, it could be the shape of the material in some cases, etc. So we're currently testing our products for 26 PFAS compounds. So there was a question asked, hey, is there certification for your products? And there is. So a lot of our products have actually gone through the water quality standards, which I think are 531. To leach our products for 24 hours in a certified PFAS-free solution, and then take that solution and get it to an independent laboratory for analysis. So we're meeting, I think, currently water quality standards, and they keep adding compounds to water quality as well as they're able to address it. So far, we've added quite a few products to our line. Like, for example, the bladder pump systems are available in both PFAS-free or with PFAS components, because some of our clients are working in environments, they have to have that PFAS material. Otherwise, the O-rings of the pump are just going to dissolve. So very harsh environments, we're going to keep that PFAS in those environments. If you're in an environment that's that harsh, chances are PFAS is not your number one concern, right? You've got something else that you're trying to tackle. Peristaltic pump was a given. Electric submersibles, we began removing PFAS from internal components as well as the motor leads. So we've gone from a nice Tefzel, inert, hard, rigid material to an HDPE. All right, so just know that HDPE is not as inert as the Tefzel. So if you're cleaning and deconning that motor lead, take extra precautions to clean it. It's HDPE, it's pretty inert, but not real inert. So clean it well, and then obviously do your due diligence and do your equipment blanks to make sure that the equipment's not contributing to anything. Disposable balers, water level meters. We've replaced some of the tapes on our interface meters, all of our tapes on our interface meters and water level meters. So interface are detecting hydrocarbons, free phase, as well as DNAPLs. The Tefzel tape was amazing, or ETFE tape was amazing for cleaning off that stuff. But now we're going to an HDPE just because the industry is demanding it. Still okay, just a little bit more due diligence to keep those materials clean. All right. Environmental tubing, soil sampling kits, and then many of our remediation systems as well. Industry response. So when we talk about, what are you analyzing for? And this is something, and again, I'm not EPA, I'm not regulatory, but if you're not sampling for FEP, right, is it really going to impact your sample? Maybe not. What PFAS compounds are you sampling for, right? We're not sampling for all 5,000 of them. I don't know anybody who is. Analytical labs can't do it at this time. But what are you actually sampling for? And then determine maybe whether or not you need a PFAS-free system, especially when you're writing your SAPs now, because they're very difficult to change later. Kind of assess that a little bit. We can help kind of assess that a little bit as well. And then, do materials of construction of the equipment that you're looking at utilizing really going to interfere with your analytical results? Yes, no, maybe. It's for more further discussion for sure. And then concerns with cross-contamination. As we know, PFAS is being monitored in parts per billion range, okay? Very low trace concentrations. But yet, we're still using equipment that's being moved from one well to the next well to the next well. I highly recommend maybe dedicating. All right, if you're really sampling for PFAS for a long period of time and they're looking at changes within that aquifer system or that surface water system, just dedicate, and then you don't have to worry about that cross-contamination, potentially getting false positives, et cetera, et cetera. Short-term approaches, source PFAS sampling equipment. So I have that source PFAS sampling equipment for 2 points. One, you can just go with PFAS-free equipment. It doesn't have any PFAS compounds in it, right? It's HDPE. It's not made up of it. However, how that product is processed, manufactured, packaged, shipped, whatever, if you're monitoring for parts per trillion, is there the potential that it may be exposed to PFAS somewhere between the manufacturing floor and to your site? Absolutely. That's why we sample for 26 PFAS compounds to make sure that we're not introducing anything. But if you're picking something up from another source that aren't testing their equipment, just know that risk applies and run those equipment blanks. Oops, let me go back. Equipment blanks. Ask good questions. Difference between PFAS and PFOS. Those are really commonly misinterpreted. PFAS is that family of compounds. PFOS is one individual compound. So if I hear PFOS, I'm thinking PFOS. Right? It's firefighting foams dispersed all over the place. It's soluble in water. It's transported all over the globe. It's a mess. That's what we're dealing with right now. But PFAS, that's a totally different animal. So let's talk the same language. And then long-term considerations. Again, dedicate your equipment if you can. Your initial costs may be a little bit more to dedicate, but the time savings of decontaminating between each well, as well as the risk of cross-contamination, false positives, and time lost from that are much greater than what your initial cost would be just to dedicate. I recommend being at the table. I know that there's some new regulations. No, I heard there's some new information about PFAS sampling and guidance, which I'll be honest, I haven't read through it yet because I just heard about it last night. But that's going to be my next step after field days, is to better understand what this new guidance looks like for environmental monitoring and sampling. And it's pretty much the same story that we've talked about. But if we're not at the table, we're just kind of waiting for things to happen. If you're part of an association, professional association, let's educate each other. Let's talk about each other from different stakeholder perspectives and help kind of create guidance that's realistic and doable for multiple industries, right? Who's being affected and what challenges do you have and how do we resolve this? Track regulatory guidance. It's constantly changing. I've been tracking this for a long time. Who's watched the movie Dark Waters? That's a good one, right? So if you haven't watched that movie, it's a good movie about PFAS and kind of some of the history and a lawyer that's involved with it. And then there's also The Devil We Know is another one. One's more of a documentary, one's more of a cinematography kind of movie. But both of them are really good and they kind of cross. But it's been a concern for a long time that we've known about. And so it's just starting to kind of, not just starting, but it continues to move towards how we're going to manage this. What are we going to do next? So, and then consider your SAP language. Again, if you're writing a sampling analysis plan now, be careful. You know, if you're in a certain type of contaminated site, and you go with a PFAS-free product, it could really create headaches for you long term. So we can kind of help analyze and assess that if you need any assistance. Some of the sources that I use, Geotech's PFAS commitment. On our website, we do have an area where it shows our certification and our detection limits for the 26 PFAS compounds that we're monitoring for, as well as our list of products that are currently PFAS free, so you don't have to sit there and navigate around our site and try to find PFAS free. Bam, it's just right there. And then also remediation equipment. What's being used, what studies have been done. We have the pump systems, we have the carbon systems to mediate PFAS. There's kind of a neat interactive map right here, linked, and hopefully we find a way to share these slides, but this interactive link will show you kind of what some of the hot spots are and what compounds are really of concern. And typically there's about 8 on the list in the environmental industry. We're kind of following the water quality standards. So, you know, in many cases we're sampling for all 26, 27, 28. Who knows how many there are now? I know they keep adding a few. Anybody know offhand? I think last I checked it was like 27. We're going to go with that for now. And then obviously utilizing credible sources for information. EPA is always a good overall guidance. And then, you know, your local, if your local states, counties, regulatory agencies are also taking that guidance, which right now they're copying and pasting in many cases. It's also a good resource for additional information. So, right on the dot. Any questions, comments, stories? Nothing? What challenges do you guys have with sampling for PFAS? Is it getting equipment that's PFAS free and trusting it maybe?
What about the tubing? Does that need a tubing have PFAS in it?
Well, what kind of material is the tubing?
Well, Teflon all the way down to the basic stuff.
So FEP does have a fluorine element to it at some concentration. So yes, that falls under the 5,000 PFAS compounds. But is it that compound that you're sampling for? And we can't, I don't know, that's the stuff so durable. Again, the tubing's great for certain environments. It's really inert, it's easy to decontaminate. It's hard to say goodbye to that kind of stuff for a lot of environmental groundwater sampling and monitoring. But at this point, it's kind of necessary, right? If we want to go PFAS free, we just want to make sure that we're not introducing something. However, if we take a bladder pump system and Teflon tubing and we leach it in a bucket of PFAS-free water, and then we analyze for it because it's full of PFAS, right? The bladder, the O-rings, the tape, the tubing, and we take it to the laboratory. We analyze for those 26, 27, 28 different compounds. Zero detect for any of those 28 compounds. So our product, we know, is not going to leach in clean water, is not going to leach into sample or change sample integrity, especially in the short term that it's in contact with it. I mean, we were leaching for 28 or 24 hours. Well, that water sample is only touching that material for seconds. So I'm still arguing the fact that, hey, I'm at the table going, wait a minute, do we really want to get rid of this material? Because I don't think it's impacting these environments and it's not creating an environmental concern. It's really good for the industries that we serve. But I need more people than myself to agree to that. Agree as well. To address your question there, so yeah, FEP, yep, it is.